Alright, welcome to the hardest page, page 4. We're going to work with number 2. Okay, like always start with what's given. The only information that is given is that we have 50 grams, 50.0 grams of CH4. We need to convert this all the way into the mass of CO2 formed. So I would write equals at the very end. We're going to do a lot of multiplying here and dividing. And we want mass, which is in grams, of CO2. Okay, the key here is to get to this point here. This is all in moles. This chemical equation tells you how everything is related to each other, like the CH4 and how CO2 are related to each other, only in moles. So what you see here is that how you're supposed to read this is, it doesn't say the number, but if there's no number, it's implied that it's 1 for every 1 mole of the CH4 chemical added to 2 moles of the O2 chemical here, or molecule. You will produce, there's no number there, so that just implies that there's 1. You produce 1 mole of CO2 and 2 moles of H2O, okay? The two things that we're looking for are how these two are related, CH4 and CO2. Over here and how they're related is that in this chemical equation, for every 1 mole of CH4 that you have, you will be able to create 1 mole of CO2. Basically what I'm trying to say is that we want to get to here, but we only have CH4 in grams. So what you need to do is you need to convert this into how many moles of CH4 we have, okay? Why is that useful? So going back here, if I know that's a ratio of 1 mole of CH4 creates 1 mole of CO2, imagine if I had 3 moles of CH4 chemical instead of 1. That's 3 times the amount here. Well, guess what? How many moles of CO2 would I create if I had 3 moles of CH4? Well, using this ratio for 1 to 1, if I have 3 times the amount that's listed here, 1 CH4, so if I had 3 moles of CH4, that would make this 3 times more, so that would be 3 moles of CO2 I would make. That's great, but I don't know how many moles of CH4 I have, so I need to convert this into moles of CH4. You need the molar mass of CH4. Normally, you would have to calculate that using the periodic table. I conveniently gave it to you in this equation, or this problem, I'm sorry. So the molar mass, oh, actually, I apologize, I did not. I gave you the molar mass of CO2. Oh no, okay. So we have to generate the molar mass of CH4 on our own. Oh, okay. I'm going to have to open up a new window with the periodic table, ptable.com. Okay. So this is what makes these problems so much longer. Okay. Take a look at the chemical equation. That's CH4. We have C and H. Okay. Carbon, 1 mole of carbon weighs 12.011 grams. I'm going to keep kind of a note of that. C, one of them is 12.01 grams. Or let's just round to 12 grams, okay? Let's look at how much H is. H is approximately 1.008. Let me just make it easier for myself and put 1 gram. Now the chemical equation was CH4. I just need one of those weights, or masses of C, that's just 12 grams, but there's 4 of these hydrogens, so I'm going to multiply this by 4. Let's add this together, 12 plus 4, that would give me the molar mass of CH4. That's 16 grams per mole of CH4. Hold on, we'll put grams of CH4 like that. Okay, so I'm going to multiply this guy by this guy, hold on, or I could report this as a fraction where I flip the placement of 1 mole CH4 on the top, and the bottom will have 16 grams of CH4 on the bottom. The question is, which form do I use? This one or this one? One of these will I will actually and only use to convert from grams to moles here? The answer is this one. I've explained it in my previous pages in the problems. I guess I'll go through it briefly here as well, but a little bit faster. I presume that you've already gone through a bunch of these problems before heading to page 4, the hardest one. Okay, the reason why I didn't go with this one is because if I went with this one, moles is on the bottom, CH4. The way it's written here, if moles was on the bottom of CH4, the grams wouldn't cancel out. These do. In the same way that like 7 times 3 over 7, the 7s would cancel out, okay? But 7 times 7 over 3, the 7s would not cancel out, but this would, okay? Okay, so if I stopped right there, by the way, I just want to erase that on the side. If I stopped right there, my answer would be in moles of CH4, okay? But I need to keep going, right? So if I stopped right there, it would be 50 times 1. These two numbers multiply and divided by 16. That would be about 3.12 moles of CH4. Okay, well that's great, but I don't want moles of CH4. I want to get to CO2. But let's convert that 3 moles. I'm not even going to write that that's equal to 3.125 moles. I'm just going to keep converting. I just know in my head, if I stop there, that's about 3 moles of CH4. We're going to multiply all this by the conversion factor I can make from this chemical equation. I know that for every 1 mole of CH4 chemical, I can create 1 mole of CO2 chemical. I can multiply this by this or this form, where the 1 mole of CO2 will go on the top, and the 1 mole of CH4 will now be in the bottom, or the denominator. Which version do I want? I want this version. Again, the reason why is I want to cancel out the 1 mole, or the units of moles of CH4. Again, I wrote in this version, okay? Here. If I use this version, the mole of CO2 would be at the bottom, and then that would mean I could not cancel out the mole of CH4 if this said mole of CO2. So the order does matter. Mole of CH4s will cancel out. The last step, because I'm not done. If I finished right now, I would get an answer of how many moles of CO2 I could create from 50 grams of CH4. I'm asking for the mass. I'm almost there. One more step, okay? If I stopped right here, I would probably get, I don't know, who knows, 2 moles maybe of CO2? But then we would want to see how much that weighs. I'm going to use the molar mass of CO2. That was what was given to me right here. The molar mass of CO2. Otherwise, I would have had to do that whole thing with the periodic table, but I don't have to here. The molar mass of CO2 is 44.01 grams over moles. What that translates to is 44.01 grams, or 1 mole of CO2 weighs that much in grams. And we're going to put of CO2. I could use this version or another version where 1 mole of CO2 goes on the top and the bottom is 44.01 grams of CO2 on the bottom. Sorry. Now, which version am I going to go with? This one or this one? The answer is this one. But why? Okay, same as I said before. I want to cancel out the unit that's on the top here and get to a new unit. So I have to pick the form where the unit on the bottom matches the unit from my last number here, or my last value that I have from here. It's this version. times, let's put 1 mole of CO2 on the bottom, and on the top is 44.01 grams of CO2. Okay, the units of moles of CO2 will now cancel out because I'm multiplying this by a ratio where the moles of CO2 is on the bottom. They have matching units, top and bottom, so they can cancel out. My only unit I have left is in grams of CO2, which is what the question was asking for, the mass of CO2, which is in grams, G. That's what I have here as well. I set it up to be to have my final answer in grams of CO2. All I have to do now is to calculate this. Hopefully you know what I'm doing right now. I'm not going to explain it as thoroughly because I've already explained it in the past 3 pages of problems. Okay, you're going to multiply 50.0 times 1 on the top, all the numbers on the top, 1, 1, 44.01. So let's do that, times 1, times 1 again, for this one, times 44.01. And then, in the same entry on my calculator here, I'm going to divide it by all the numbers on the bottom individually. Divided by 16, then divided by this 1, then divided by this one. This 1, no, this value, or number of 1. Let's press enter, and my answer is 137. I got 0.5, okay? And that's perfectly fine. Just note that that's a few decimal places off from what the key says here, and that's okay. As long as it's in 137 land, we're good, okay? Now, if that said like 300 or 200, then you're wrong. But a few decimal places off is okay. In case you're wondering why I did that or why it came out that way, it's because when I calculated the molar mass of CH4, remember, I rounded a bunch of those numbers, or remember, I was like, 12, and I rounded that to 12. I don't know if you remember. But anyways, that's it. Okay.